We have 5 examples regarding the derivative of logarithmic functions. The first example is ln of sine to the 6th power of x minus tangent x. So the sine to the 6th power, take the 6 out. That is sine of x raised to the 6th power. The 6th power has nothing to do to the x. So this one means whatever x is. So let's say x is pi over 2. You find out what sine of pi over 2 equals to, and then you raise the result to the 6th power. So you do not raise the x to the 6th power. The derivative of sine of x is 1 over x, so you have 1 over everything in the parentheses. This is a sine to the 6th of x, and then minus tangent x, and then you multiply the derivative of the parentheses, so you bring the 6 down, and then you have sine x, and then raised to the 5th, and then what else? The derivative of, let me tell you this. Okay, if you just keep the 5 in there, do we agree that it is easy to miss the derivative of sine, right? If you put a sine, you might be thinking, all right, we took care of the sine, and then the next one is x. The derivative of x is 1, so we are done. So let's move on to the derivative of x. That is wrong. All right, so I don't recommend you to put the 5 in there unless you have very good experience in handling this. So otherwise, I highly recommend you to keep the 5th power outside like that, and then multiply the derivative of sine, which is cosine, and then minus the derivative of tangent is secant square. So this is all by chain rule. So chain rule. And then from the sine to the cosine, there is another chain rule. So that is the answer to the first example. The next example, we have f of x equals to ln 3x minus the square root of x to the 4th plus 2. So for ln derivative, we bring everything to the denominator. So we have 1 divided by 3x minus the square root of x to the 4th plus 2, and then we multiply, chain rule, right? So we multiply, so this is a chain rule. The derivative of 3x is 3, and then you bring the 1/2 down, we have x to the 4 plus 2 to the negative 1/2. The derivative of this parenthesis is 4x squared. 4x squared is 4x to the 3rd power plus a 0. So you put the entire square bracket to the numerator. Okay, for the simplification, you can simplify the 4 and the 2, and I guess that's it. So for the next problem, we have ln. We have g of x equals to ln x times e to the negative 6x. So this one I have to remind you, there is a formula for ln. So for ln a times b for multiplication, you have ln a plus ln b. So you can break this down into 2 ln. So the first term is ln x, and then plus ln e to the negative 6x. The benefit of doing this is you can bring the negative 6 down. So the other rule is ln a to the nth power. You can bring the n down to the front of ln. So you have ln of a. So bring the 6 down, ln x no change, bring the negative 6 down, and then you have multiply ln e, and then also ln e is equals to 1. Okay, ln e is equals to 1. So now you take the derivative. The derivative of this, what is that equal to? The derivative of ln x is 1 over x, and then the derivative of 6x is just a minus 6. Yes, it is just that simple. Just that simple. Imagine how complicated it will be if you don't do this. So if you don't do this, you have to take the put this first, so x e to the negative 6x, and then you have to multiply the derivative of x e to the negative 6x, which requires a product rule. So if we simplify the function first and then take the derivative, we have a much easier life in this way. Okay, the next one, we have a k, right? So let's do a k. So the next one is what we have, k equals to ln of of ln 2x. What is the derivative? The derivative, first we take care of the first ln. So we have 1 divided by the entire ln of ln 2x down here. Okay, and then we take the derivative of that. So take the derivative of that. That is 1 divided by ln 2x. And then we take the derivative of that. The derivative of ln of 2x is 1 divided by 2x. And then the derivative of 2x is 2. So we have a chain rule, and then a chain rule, and then a chain rule. The first chain rule is for this ln. So for this ln, we bring this piece down to the denominator. And then we multiply the derivative of this denominator. So that, and then we are taking care of this ln. So we bring the ln 2x to the denominator. And then we take care of this ln, bring the 1 over 2x, bring the 2x to the denominator. And then we take the derivative of 2x. We have a 2. Okay. All right. The next problem is also very, very interesting. Let's take a look. The next problem, you have a z equals to ln. That looks very complicated, right? You have 4x to the third power minus a raised to the 6. You might be thinking, oh my God, that will be, you take the 6 down, and then you have 5th power, and then you have a product rule, right? And then next you see a square root in the denominator. You might think, oh, that is even worse. We have to do a quotient rule, huh? But let me tell you this: when you see this situation, think about the properties of ln. So the first thing you have to think is ln a divided by b. You study this in a pre-calculus and intermediate algebra. That is ln a minus ln b, right? And then the next thing is ln a raised to the nth power. You can bring the n down to the front of ln a, right? So this is, we have numerator divided by denominator. So we split this up to 2 ln first. So ln 4x to the third minus 8 raised to the 6, and then minus ln square root 1 minus 5x. And then we bring the 6th power down. So bring the 6th power down, ln 4x to the third minus 8. And then bring the 1/2 down, ln 1 minus 5x. And then I have to remind you that we haven't done any derivative yet. Once again, we haven't done any derivative yet. I just used the properties of ln to rewrite the function. No derivative has been done. And then for the minus, for ln one term minus the other, so this cannot be simplified. There is no way to rewrite this. So no way to rewrite this. Also for the plus, ln a minus b, a plus b. That's it. Nothing else we can do. So now we take the derivative. Derivative of ln, you bring this to the denominator, right? So 4x to the third minus 8. There should be a 1 on top, but you have a 6 in front, so that is a 6. And then you multiply the derivative of that. What do we have? We have 12x squared minus 0. Okay, this is finished. And then minus, the minus comes from here. Minus, you bring this to the denominator, 1 minus 5x, and then you still have your 1/2. And then the derivative of 1 minus 5x, 0 minus 5, right? Which is just a negative 5, because that is linear, right? 1 minus 5x is linear, so the slope is negative 5. And then you can clean this up by doing z prime equals to, you have a 4x to the third minus 8. So this is a 72. And then plus 5 divided by 2, and then 1 minus 5x. Or you distribute the 2 in. Okay, so that is the plus is from this minus and this minus. So that is the end of this video. If you like it, you think my teaching matches your learning, give me a like, share the video for me. I truly appreciate your help, and I will meet you all in the next video. Signing out.